figure out how to successfully calculate the winding of long products in WinderCAM. Let's take a long rod as an example. Here is its drawing, a profile consisting of 5 cones with flat end faces. If we try to input this profile into the system directly, we're headed for failure.
Failure? Why? The profile's clearly defined.
It's all about the mathematics. At the points where the cones meet, there are sharp jumps in the second derivative, both positive and negative. This breaks the calculation. So we use a clever workaround. We replace sections of the composite polyline with fragments of second-order curves.
So we're intentionally distorting the geometry? Is that acceptable?
Absolutely. A slight deviation in the profile is permissible. The laying process is stable, and these sections are traversed in fractions of a second. The crucial points are the smoothness of motion and controlling the thread's release speed from the tensioner. This minimal modification of the generatrix allows us to calculate a smooth turn.
Okay, smoothness is clear, but what about holding the tape at the ends? There could be issues there.
You're quite right. For reliable fixation at the ends, additional mechanical devices are sometimes used. For example, a set of pins arranged around the end face. But there's another, more subtle issue, the layer thickness.
What about the thickness? If we follow Clairaut's equation, the material will thicken towards the narrow end.
Precisely, and a reasonable engineering requirement is a uniform thickness along the entire axis. Although this feature isn't in WinderCAM yet.
Oh, so there are blind spots in your system?
We admit it. If our esteemed colleagues are interested, we'll implement it in the next version. By the way, if you need to determine the reinforcement angle on the actual surface, you need to solve the direct winding kinematics problem. It's an inverse formulation, but it's also solvable, if the customer has the desire.
Well, thank you for the details. It seems with your recommendations, the calculations can indeed be successful. We'll give it a try.
We sincerely wish you luck, and we await your requests for new features.